Hi students, let us continue the one more or next application of derivatives, that is rate measures or rate of change of quantities. Rate measures or rate of change of quantities. Now, what is meant by rate measure or rate of change of quantities? Word telling that rate of change of quantity. Suppose in a previously people already know that, or suppose consider y is equal to f of x. Y is a function in terms of x is that. Now differentiating with respect to x. Differentiating with respect to x. After differentiating with respect to x, what we people used to write dy by dx is equal to f dash of x. Dy by dx is equal to f dash of x. And there is a two variable x and y. X is an independent variable, y is a dependent variable. The dependent variable is differentiating with respect to the independent variable. Dy by dx is equal to f dash of x. Symbolic form is that means y is changing with respect to x. Y is the rate of change of y with respect to x. More elaborately, we can discuss that. For example, S is nothing but a displacement. S is nothing but a displacement. S is defined in terms of t. S is defined in terms of t. S is a displacement with respect to the time. Displacement of the particle or whatever the quantity is that with respect to the time. Differentiating this value, that means ds divided by dt. Differentiating displacement depends on the time. Time is not depends on the displacement. So displacement is depends on the time. Differentiating the s with respect to time. Y is depends on x. Okay, differentiating with respect to x. S is depends on t. So displacement is depends on time. Differentiating displacement with respect to the time. This is nothing but in a physical word that we just say that velocity. Velocity is denoted by v. Then again it is differentiating with respect to time. That will get dv by dt. Differentiating the velocity with respect to time, that will get it as a acceleration, that is denoted by a. So these are the physical quantities. You should all know that this is the meaning of rate of change of one quantity or rate of change of quantities. Rate of change of one quantity with respect to the another quantity. Here I just directly go to the example. So what is the example? Suppose the radius of the circle is 2 centimeter. Radius of the circle is 2 centimeter. What is the rate of change of its area? What is the rate of change of its area? What is the question? So whenever the radius of the circle is 2 centimeter, then what is the change of its area of the circle? So already we know that area of the circle. What is the area of the circle? Area of the circle is equal to pi r square. So area is depends on the radius of the circle. If radius is changing, if the radius is increasing, area is also increasing. If the radius is decreasing, area of the circle is decreasing. So differentiating this area, differentiating the area quantity with respect to the radius. I just write that dA with respect to radius r. So pi is a coefficient and the constant keep as it is. R square differentiation is 2r. With respect to r only I am just differentiating, which is of the form x square to x. So now we just get so dA by dr. So dA by dr. Whenever r is equal to 2 centimeter. Therefore 2 pi r is 2 centimeter. Finally 4 pi square units. So rate of change of area with respect to the radius is 4 pi square centimeter whenever the radius is 2 centimeter. This is how the examples will be as. Now let's take some examples based on this definition. So this is the rate of change of one quantity with respect to the another quantity. Yes. The second example is the volume of the tube is increasing at the rate of Volume of the cube is increasing at the rate of 9 cubic centimeter per second. How fast is the surface area is increasing when the length of an earth is 10 centimeter. Okay. Here, depending upon the given data, they are given a cube. So already know that cube. What is the shape of the cube? I just take the rough diagram of the cube. Suppose the cube is in this manner. So cube, all the lengths are same. If I take this x unit, this is also x, this is also x. Length, breadth, and the height of the cube, x, x, x. So here, the volume of the cube is increasing at the rate of 9 cubic centimeter. Already know that. First of all, write the given data. Here, in this type of problems, or we just say that this type of problems are word problems, we just need to get the one rough diagram. Based on that rough diagram, what they have given, clearly write that one. They have given that cube, the volume of the cube is increasing. That means rate of change of volume they have given. What is the rate of change of volume? With respect to what? Increasing at the rate of 9 cubic centimeter per second is that. Per second means the rate of change of the volume of the cube is changing with respect to the time. So that dV by dt is given. How much it is given? 9 cubic centimeter per second. 9 cubic centimeter per second. This is the first quantity. Next, how fast is the surface area is increasing? How fast is the surface area is increasing? That means surface area, I just choose it as yes, with respect to time is increasing. Which rate? How fast is the surface area is increasing? Here with respect to time is that obviously it is also with respect to the time. This quantity we need to find. And then was how fast is the surface area is increasing when the length of an earth is 10 centimeter. That means length of the earth is 10 centimeter is that. So at x is equal to 10 centimeter we need to find. So already know that the volume of the cube. What is the volume of the cube? Here x is the side and I just taken x cube. And surface area is equal to how much? 6 times of x per total surface area. How many faces it has? The 6 faces it has. So it has 6 faces are there. So one face area length into breadth. Like that 6 faces are there. So 6 times of x per. Volume is that volume length into breadth into height, that will get the x cube. Now we need to find that rate of change of surface area, provided that they are given a x. If I differentiate this value with respect to what? Differentiating with respect to the x or with respect to the time here, because with respect to time they are asking. With respect to time, what happens? ds divided by dt. ds divided by dt is equal to 6 is the coefficient as it is. X square differentiation is 2x. 2 into 6 is 12 times of x. But here we are differentiating with respect to the time, so that d2 we now write it as a dx divided by dt. Why is dx divided by dt? Means, for example, we just go back to the differentiation. What is the differentiation? Suppose x is a quantity in terms of t and y is a quantity in terms of t. This type of function we just say that parametric form. So I need to find the totally the dy by dx. How to find the dy by dx? For finding the dy by dx, I need to differentiating x value with respect to the time as well as differentiating this value with respect to the time. That will get the dx by dt. Here we get the dy by dt. Finally, we need the dy by dx. For writing that or getting the dy by dx, is it sufficient to write that dy by dt? Both thing divided by dx by dt. dt get cancelled once again dy by dx. So this is how we have to solve it. In the same manner, how to get this one? By using the chain rule again. By using the chain rule differentiation. So we'll get this result. Now actually we don't know the dx by dt. Let us try to find out. So they have given one more quantity, rate of change of volume. Still yet we have not used that one. So that get our differentiating this value with respect to what? T. Differentiating with respect to the time. What will get? dp by dt. Differentiating value with respect to the time. X cube differentiation is 3x square. But I am just differentiating with respect to time. So that change to dx by dt. Now replace it. Whatever the values they are given. Do you know that dv by dt? Yes, they are given dv by dt as 9 is equal to 3x square. Do you know the dx by dt? You don't know dx by dt. Keep as this. Now from this we get the dx by dt. What we get the dx by dt? Take all the terms into left hand side. 9 divided by 3x square. 3 ones are 3 3s are. Finally we can write it as a 3 divided by x square as a dx by dt. That means rate of change of side length with respect to the time is 3 divided by x square. 3 divided by side length square. So using this value into here, what will that? Or else we can call this as equation number 1. From the equation number 1 implies that what is that? ds by dt. ds by dt is equal to 12 into x into dx by dt. What is the dx by dt? 3 divided by x square is the 3 divided by x square. Simplify. X on the x on the 1x can cancel. 12 these are 36 into 1 divided by x. So this is the ds by dt. But have you got the required result? No. They have given that how fast is the surface area is increasing when the length of an edge is 10 centimeter. Length of the edge is 10 centimeters. That they given, so that we can continue. ds rate of change of surface area with respect to the time whenever length of an edge is 10 centimeter. Wherever x is there, replace the 10. What will you get? 36 divided by 10. Finally, we can write it as 3.6. And just mention the unit. What is that? Surface area with respect to time is that. Surface area is nothing but 6 times of x square. That means centimeter square per second. This is the required value of rate of change of surface area with respect to the time at or when the length of an edge is 10 centimeter. This is how we have to solve the problem. Here, how to recognize with respect to the time or with respect to the side length depending upon the given unit with respect to the or given unit on the problem. Here observe that volume is increasing with respect to the what? With respect to the second is that. Second means we have to consider it as a time. Suppose instead of giving the cubic centimeter per side if they given per side, instead of taking here dv by dt, we have to take it as a dv by dx or dv by whatever the quantity. Here I am just using the x as a side length, so that is a dv by dx value. So very clear, depending upon the given unit only, we can recognize that with respect to which quantity they are given. Very simple, and this type of problems may ask for the 5 marks session for the annual examination or 2 marks, like that the question will be arise. So very simple, and first of all try to write the given data and what we need to find. Depending upon the known formula, we can easily find the required result. Yes, the next problem is. Yes, now I just directly move to the exercise. In that first problem, find the rate of change of area of the circle with respect to its radius. When r with respect to the radius r, when r is equal to 3 cm. Second case, when r is equal to 4 cm. While explaining the rate of change of quantities, I just taken this type of problem. And in the previous problem, you can observe that they are not given with respect to which quantity. They are directly given a rate of change of volume 9 cubic centimeter per second. Instead of giving here with respect to the particular quantity, that is with respect to the radius we have given. So that means we have to differentiating given, or we have to differentiating with respect to the radius. First of all, write the given data. What is that? Or find the rate of change of area of the circle. Rate of change of area of the circle. Area of the circle, rate of change of. With respect to what? With respect to what? Means with respect to its radius is that dA by dr value we need to find. Rate of change of area of the circle with respect to its radius whenever r is equal to 3 centimeter, and second case whenever r is equal to 4 centimeter. So this is second one, we can do it as a homework. First one I just solve it. So we know that we need to find out. So we know that area of the circle. What is the area of the circle? Area of the circle is pi times of r square. Pi r square. Now differentiating with respect to what? Differentiating with respect to time or with respect to the radius? With respect to the radius, because they have only given that with respect to its radius. So differentiating with respect to the radius r. So dA divided by dr is equal to directly I just write pi is the coefficient as it is, r square differentiation is 2r. With respect to r only I am just differentiating, that's all. Now we need the area of the circle whenever r is 3 centimeter. Replace it dA divided by dr whenever r is equal to 3 centimeter. Wherever r is there, replace it as a 3. Finally we just get 2 3s are 6 5. Left hand side dA divided by dr, rate of change of the area of the circle whenever radius is 3 centimeter. What will be the unit? Unit will be the argument. Centimeter is the centimeter square per centimeter, or simply we can write it as a centimeter. That's all. Because centimeter square per radius is that radius is measured in terms of centimeter, so that is a centimeter per centimeter square per centimeter. Very simple. And second case you can easily solve it as or take it as a homework problem. Yes, the next problem is the volume of the cube is increasing at the rate of 8 centimeter cube per second. How fast is the surface area is increasing when the length of an edge is 12 centimeter? The same type of problem is already solved in the previously. So we can pause the video and solve it. Later you can cross verify your answer. Okay. Now I just directly begin the solution. I think no need to give explanation. So let us have a look. First of all, write the given thing. What is the given that? The cube is the cube already know that having the same rough diagram. Suppose it is a cube is that it has the 6 faces, length, breadth and height. So we have already known that volume of the cube. What is the volume of the cube? X cube, length into breadth into height. Surface area we know that. What is the surface area? 6 times of x square. Now what is the given? The volume of the cube is increasing. Volume is increasing. How much it is increasing and with respect to what? Volume is increasing at the rate of 8 centimeter cube per second is that. That means dV by dx or dV by dt. Here dV by dt because per second they are given. So that is it. So that will be 8 centimeter cube per second. This is given. Next, how fast is the surface area is increasing? What we need to find is the change of surface area with respect to the time we need to find, and edge having 12 centimeter at x is equal to 12. So differentiating particularly this value in terms of x is the surface area in terms of x is the, and after differentiation it is sufficient to replace the x value as a 12. So I just differentiate this value. First of all, we know that value is x cube. Differentiating with respect to the time because dV by dt is given. So dV by dt is equal to 3 times of x square. I am just differentiating with respect to time, so that here into dx by dt because of the chain rule. Now dV by dt is given as 8 centimeter cube per second is equal to 3x square as it is, dx by dt as it is. From this we get the dx by dt. What is the dx by dt? Dx by dt is equal to 8 divided by 3x square. Now apart from this, dx by dt which is got from the value. Now we need to find the rate of change of surface area. So that, and again we know that surface area is 6 times of x square. So again differentiating with respect to what? With respect to the time itself, because rate of change of displacement with respect to time is equal. And again if you have a confusion with respect to time, how do you come to know that? Depending upon the given value per second is that, so it is sufficient to differentiate with respect to time. ds by dt is equal to 6 to the 12 into x, differentiating x with respect to the time, that means dx by dt. So replacing all the value, what we get? ds divided by dt is equal to 12 into x. dx by dt is here 8 divided by 3x square. 8 divided by 3x square. So cancel. 3 ones are 3 fours are 12. One of the x get cancelled. Remaining value 4 into 8, 32 divided by x. This is the ds by dt. But we need at particular side length is given, or edge of an side, and the edge of and the length of an edge is 12 centimeter. So that ds divided by dt when the side length or edge is how much? 12 centimeter. Wherever x is there, replaced as 12. Now 32 divided by 12. So it is not a multiple of 12. So I just cancel 4 3s are 12, 4 8s are, and so it becomes 8 divided by 3. 8 divided by 3 can be also replaced as 2.3 2s are 6, 2.6 like that. 2.6 or 8 by 3, that's enough. What is the unit? Unit. Surface area is that centimeter square per, with respect to time is that per second. You can stop at here or you can stop at here. None of the same. Centimeter square per second. We will get the full marks at here. This type of question will ask for 5 marks. Okay. Now the next problem is, yes, what is the given problem is, the radius of a circle is increasing uniformly at the rate of 3 cm per second. Find the rate at which the area of the circle is increasing when the radius is 10 cm. Suppose the circle is there. Circle is the center, and I just choose that as a radius r. The radius of the circle is increasing. Radius is increasing. Radius of the circle is increasing means rate of change of the radius with respect to what? With uniformly at the rate of 3 cm per second is that. So rate of change of the radius is dr by dt. I am just taken with respect to time because of this unit. This value is 3 cm per second. Rate of change of or radius of the circle is increasing. Increasing is the changing. Increasing or changing, none of the same. Then find the rate at which, we need to find the rate at which the area of the circle is increasing. Rate at which the area of the circle is increasing. Obviously, we need to take that dA by dt is equal to how much? When it is, whenever area of the circle is increasing, when the radius is 10 cm. Whenever the radius is 10 cm. This radius is 10 cm and radius is increasing at the rate of uniformly at the rate of 3 cm per second. At radius is 10 cm. What is the change of area of the circle with respect to the time? So very simple. We have just written the given data and what we need to find. So I am just going to write that. We know the area of the circle. It is area of the circle pi times of r square. Differentiating with respect to what? With respect to the radius or with respect to the time? Here with respect to the time because of per second is that. So differentiating with respect to the time. What will we get? dA by dt is equal to pi as it is. R square differentiation is 2 times of r. I'm just differentiating with respect to time, so that dr divided by dt as using the chain rule. Now replace whatever the quantity we know that. We know the dr by dt. Replace it 2 pi dr by dt value. What is the dr by dt value? 3 is and this we need the dA by dt value. Whenever r is 10, so r value is 10. Simplify. So 10 into 3, 30, 32 is 60. 60 times of pi. Rate of change of area with respect to the time. Whenever radius is 10 centimeter, is 65. What will be the unit? Unit is centimeter square per second. Why I am just taking a centimeter square means area. R square is okay, R square. So that reason I am just taking centimeter square, and with respect to the time I am just differentiating so that per second. Hence the solution. Now the next one is an edge of a variable cube. An edge of a variable cube is increasing at the rate of 3 cm per second. How fast is the volume of the cube is increasing, and the edge is 10 centimeter long. Cube is the preferably given based on the cube. So suppose the cube is in this manner. I just taken a side length as a x, length, breadth, and the height of the cube. Okay. And edge of a variable cube. Variable cube is changing its length. And variable cube is the edge of a variable cube is increasing. That means side length is varying, changing. So side length is changing is nothing but x is changing. With respect to what? With respect to second. With respect to the time, because the rate of variable cube increasing at the rate of 3 cm per second is that. So dx by dt is given. How much? 3 cm per second. Next, how fast is the volume of the cube is increasing? That means we need to find the rate of change of volume with respect to again time is equal to how much? Whenever how fast is the volume of the cube is increasing, whenever x is 10 cm, whenever x is equal to 10 cm. Okay, here if you have any confusion, suppose y is equal to f of x is the differentiating with respect to x, that will get it as a dy by dx. dy by dx is equal to f dash of x. Here I am just writing dv by dt at x is equal to 10 and dr by dt at x is equal to or r is equal to 11. That means at a particular point x naught comma y naught. As we know that first order derivative is the slope of the tangent. Slope of the tangent at x naught comma y naught. That means dy by dx at x naught comma y naught. If x and y both values are there, then replace x value as x naught, y value as y naught. Here particular point is that. For example, 1 comma 2. X naught comma y naught is nothing but particular point 1 comma 2. Here in the right hand side only in terms of x is there, so that I just replace x value as x naught value. This is how the exact meaning. Now here we need to find that rate of change of volume of the cube with respect to the time. Whenever edge of the cube is 10 cm, edge is nothing but side line. Okay, as we know that I just use the volume formula, because volume rate of change of volume we need to find. What is the volume of the cube? X cube. So differentiating with respect to what? Differentiating with respect to the time, because dv by dt is different. So what will get? dv by dt is equal to 3x square. But I am just differentiating with respect to time, as according to the formula of the chain rule, dx by dt. Now replace all the values, will get answer. So dv by dt is equal dv by dt is equal, and whenever x is equal to 10 cm, 3 into x value is 10 square, and dx by dt is given, that is the 3. Final answer. 10 square is 100. 100 into 6, that means 600. So 10 square is 100. 3 3s are 9. The total value is 900. 900. And what will be the unit? volume is x cube is that, so centimeter cube per what? Centimeter cube per time, that means per second. It is sufficient to write. This is the required rate of change of volume of the cube whenever edge is 10 centimeter. It is 900 centimeter cube per second. Now, yes, the next one is a stone is dropped into a quiet lake and waves move in a circles at the speed of 5 centimeter per second. At the instant when the radius of the circular wave is 8 centimeter, then how fast is the enclosed area of the is increasing? Okay. A quiet lake means you already know that lake. Correct. Okay. Lake is the quiet lake. There is nothing is disturbance for the water. A stone is dropped into a quiet lake. If we throw one stone into the lake, the waves will be formed. Already you might have the experience in a childhood. You might have experience. So if you throw one stone, the circular waves will be formed. How the circular waves will be formed? At the here the stone is dropped, then the circular waves will be formed. Whenever a stone is dropped into a quiet lake, a circular waves will be formed. Circular waves will be formed means, can I take it as a circle? Circle is that. So circle is the radius of the circle, area of the circle. Radius is changing at this moment. Suppose if I taken this as the radius, this radius is R1, this radius is R2, and this radius is R3, this radius is R4, like that. At the different, instead of time, the radius of the circle is increasing, R1, R2, R3, R4, R5, like that. The radius is increasing. Whenever the radius is increasing, obviously the area of the circular waves is also increasing. Circular waves is nothing but as considered as a circle. Now, according to this, what is the key one thing? Very clear problem. I think you have clear about this word problem. A stone is dropped into a quiet lake and waves moves in a circles. The particularly mentioned in terms of circle at the speed of 5 centimeter per second. Then what is this value? 5 centimeter per second is, what is this value? This is nothing but rate of change of the radius. Rate of change of the radius with respect to what? With respect to the time. They have given dr by dt is equal to how much? They have given 5 centimeter per second. Or else if you are not get this one, read the sentence very clearly. You will get the idea. Stone is dropped into a quiet lake, okay? Then and waves move in a circles. These are the waves move in a circles at the speed of 5 centimeter. Waves are moving. That means radius is increasing with respect to the time. So rate of change of radius with respect to time is 5 centimeter per second. Next, at this instant, when the radius of the circular wave, these are the circular waves, when the radius of the circular waves is 8 centimeter, whenever r is equal to 8 centimeter, whenever radius of the circle at this moment, suppose this radius is 8 centimeter, at this instant we need to find that how fast the enclosed area, this is a closed area, how fast is the enclosed area is increasing. That means we need to find that rate of change of area of the circular waves with respect to what? With respect to the time, whenever r is equal to 8 centimeter. Yes, very simple. And now we know the formula. What is the formula we are going to use here? Radius is the rate of change of radius and rate of change of area is required. So area of the circle is pi r square. Differentiating with respect to what? Differentiating with respect to the time. That's all. dA by dt is equal to how much? 2 pi r. And I'm just differentiating with respect to time, so that change rule dr by dt. Replacing all the value. 2 as it is, pi as it is, radius value is given at the 8 centimeter, and dr by dt is given. What is that? Pi. So finally you can write 8 into pi. 40. 42 is 80. 80 pi. This is the rate of change of area with respect to time whenever r is equal to 8 centimeter. What will be the unit? Unit is area by r square is a centimeter square per second. This is the required answer. Okay. Now, this is the required answer as 80 pi centimeter square per second. So, very important type of problem for 3 mark session as well as 5 mark session. Now, I just stop here. The remaining problems will continue in the next video. Thank you.